Hi everyone, this is Mrs. Herbert. I'm excited to bring you this mini lesson on types of data distributions. All right, to get started, let's take a look at this simple example of rolling a fair die. Now, what makes a die fair is if you have the numbers 1, 2, 3, 4, 5, 6 only one time on each side of our die. So if we were to plot those different outcomes on a line plot, we would just put a single X above each of the numbers 1, 2, 3, 4, 5, and 6. So this is an example of what we call a uniform distribution. This is a type of distribution whose shape is level, so it sort of looks like a rectangle. Okay, to demonstrate our second type of data distribution, let's consider this example. Let's say that 12 employees at a small company make the following annual salaries, and this is in thousands of dollars. So you'll see that we have salaries ranging from $25,000 all the way up to $55,000. So if we create a line plot using this data set, we've got one employee making $25,000, someone's making $30,000. We have 3 employees making $35,000, so that's where we're just going to stack all 3 X's over the 35. We have 3 employees making $40,000. 2 are making $45,000. 1 is making $50,000. The last employee is making $55,000. So we're going to assume that that is the big boss or the CEO. So this is an example of what we would call a normal or symmetric distribution. If we think about the word symmetry from geometry, we should expect to see the same amount of data on either side of the graph. So this is a distribution that's mounded in the middle with symmetric tails. The tails are those ends on the left and the right. And this graph sort of looks like a bell. So sometimes this is referred to as a bell curve. Now we're going to work with that same data set, but let's consider a couple of questions now. Here's the first one. What if the highest paid employee got a $15,000 raise? So the boss decided she needed to make more money. So instead of making $55,000, the boss is now making $70,000. We would consider that $70,000 data point to be an outlier because it doesn't really lie within the range of majority of the data. So what that value has done to our data distribution is it has skewed it to the right. So we would call this skewed right, meaning that the tail on the right end of the graph is longer than the tail on the left side of the graph. Let's consider the second question here. What if the company hired a college intern for a year and gave them a $10,000 salary? So we're going to keep the boss's data the same. We're going to say that the boss is still making $55,000, but now we're introducing this extra data point here on the left at $10,000. We would consider this to be an outlier as well because, again, it doesn't really lie within the range of majority of our data set. So what that's caused the data to do is become skewed left. So now the tail on the left end of the graph is longer than the tail on the right side of the graph.